Want to go from hating to loving math? Subscribe to David Ng's channel to learn new ways to do math.
There. Period 4. LO is our learning objective. I can simplify radical expressions. Okay, the word simplify just in math is to make simple, right? 1 plus 2, you simplify it, that's 3. The word radical is the same word as square root, which is just that number 2 in that symbol. Okay, so radical and square root are essentially the same. Square root is just more specific to that number 2 right there. So it's better if you just say radical. What is it, class? Radical, right? They do that. Surfers usually do that. And then the word expression just means that there are no equal signs. Expressions means that there are no equal signs. No equal. Okay? You don't have that over here. Okay, so today a trick is I want you to underline the word a perfect square. Your life will be easier by the end of the lesson is if you can just figure out what a perfect square is and how to use it. So what is a perfect square? A perfect square is a number whose square root is an integer. Half of the first 300 perfect squares are listed for you. Fill in the other 15 perfect squares. I think you'll catch a pattern, okay? So I have the number 1 here, and I also have the number 1 here, but it seems like that number is now I can just do 2, and then an exponent, 3, 4, and then you have 5. Okay, so if I already know that the answer is going to be that number, 2, 3, 4, the question is, what goes inside the radical sign, that house? Well, it was a new school year, I needed new shoes, so I went to Nike.com and I typed in black Air Force Ones. So when I wear my black outfit, I wear Air Force Ones. And so if I was rich enough, I would have ordered 2 Air Force Ones. But what does it say in my shopping cart? What does it say? Does it say Air Force One, Air Force One? No, it says quantity. So an exponent is a quantity of how many. Does that make sense? So that means this number 2, the base is written how many times? 2 times by multiplication. So 2 squared is 2 times 2. Now let me explain to you why they call it square. So let's circle that number. Let's draw a square. This summer I went camping, and of course at nighttime at the campfire, what do the kids want? They want s'mores. So let's pretend these are chocolate pieces. Okay. Class, what is 2 squared or 2 times 2? What's the answer? 4, right? Where do I get 4 from in my chocolate? Look, 1, 2, 3, 4. There are 4 chocolate pieces. But if you count the sides, 1, 2. That means it has a side length of 2. And this side also has a side length of what? 2. Oh, that means if you write them together, they call this 2 squared. That's why we call it squared. Anything has a power of 2, okay? So, what does that mean for the square root? 4 can be written as 2 times 2. I gotta tell you my famous story. It's actually real. 19 years ago, I asked my students, they asked me, what are you gonna do this weekend? I said, I'm gonna run in the park. And I asked them, hey, you guys run in the park? And it was quiet. And I said, why are you guys quiet? He said, well, you don't run in the park at night, Mr. Ing. I said, why not? He says, you can get stabbed. I said, whoa. So in this neighborhood, it will tell you a sign. The formal math is called index. All of these numbers are, what number am I writing there, class? 2. It's an invisible 2. And it's telling you that you need 2 of the same number, sorry it's blurry, in order to come outside of that house. Okay, so watch this. You have a pair, right? You have 2 of them. It can come outside. But when you get in the house, you're comfortable with your parents, you feel safe. But when you're outside the house, you gotta watch your back, right? Someone could stab you. So when you see those pair from far away, when they're outside the house, they're cuddled up right next to each other, right? So you only see 1 number. How many numbers, class? Did you notice when you come outside, from inside to go outside, now you only have 1 number. That's why it's 2. Okay? Okay, let's go through and finish the rest of these, and then you can talk to your partner. Let's do purple. Let's do the next one. Class, 3 squared is what? 9. 3 times 3 is 9. Okay, the square root of 9. You can break it down into factors. Class, what 2 numbers multiply to be 9? Oh, the 2 3s. Oh. And do you have a pair of them? Yes. What comes out here, class? Just the 3 is your answer. Okay, let's try one more. Let's try the 4. Class, is 4 squared 8? No. See, the common mistake is going to be that you think it's 4 times 2. No, it's the shopping cart. You have 2 of these. 4 times 4 is 16. So the square root of 16 is what? The pair of 4s, right? There's a 2, comes out, then it's just 1 number. Okay? Green chairs. This one. What do we got? What do you put in here? 36. The square root of 36, the answer is 6. Green chairs, what do you put over here? 6 squared is 36. Now, some student asked me, Mr. Ring, should I split them up like this? I know it's easy, but I want you to learn to do that because when we go back to the other page, there's no more perfect squares, and you need that practice. Okay, red chairs. Let's do this one down here. Red chairs, what do I put in there? What is it? Inside? 64. What goes here? 8. What goes in the next one? 8 squared is 64. All right, blue chairs. You guys got the next one. 81. 9 over here. 81. Okay, so what we have to do here is find something called perfect squares. Now, if you didn't know, this 2 there is, how do they say that, class? 10 what? 10 squared. What does that mean? That means the side length is 10 and this side is 10. So I've been looking for shoes, and so if I buy shoes, I buy the same pair of shoes, you add both of them to the cart. You don't say add cart, you say add cart, add how many? 2, count 2, or quantity 2. So this means 10 times 10. It does not mean 10 times 2. Well, 10 times 10 is what? Well, I'm not going to draw it, but can you imagine 100 pieces of chocolate? I'm not even counting, I'm just drawing it. Right, the side length is 10, and the other side is 10, so inside is 100 pieces of chocolate, or 10 squared. Are you following me? So let's review. There are 100 pieces. The side lengths are both 10. They're the same. It's called 10 squared. Well, that helps us understand square roots. So I have a square root. This is like, student friendly. It's a house, okay? And inside this house, it's telling us there's the number 100. I told you before there's an invisible number up here. Class, what number is that? So it's saying I need 2 identical numbers inside that house. Okay, so I'm going to tell you a very scary story, okay? I asked my students, hey, what are you guys doing after school? They asked me, what are you doing? And I said, well, I'm going to run around the park tonight. And then they said, Mr. Ng, you don't run around the park around here. I said, why not? I said, they're going to get stabbed. I was like, what? I'm not going to run around the park then. So in this scary neighborhood, to get outside the house, you need 2 identical numbers. Do you guys see 2 identical numbers? Yeah, circle the pair of 10s. Circle them. You see, when you're in your house with your family and your parents, you feel very safe. But once you step outside that house, you got to watch your back. Now, in those 2 numbers, you're not going to see 2 10s. You're only going to see how many? 1. Because when you see them from far away, they're really close to each other, right? They're like, we don't want to get stabbed. We're watching each other's back. So you have just 1 number out here, okay? Square root of 100 is 10 times 10. They're a pair that comes out. There's nothing left inside the house. Your answer is what? 10. Let's try another one. Let's follow the pattern. This is 10. What's the next number? 11. Class, what is 11 times 11? 121. So let's write that, 121. The square root of 121 is 11. Another way you can say of it is 2 identical numbers that multiply to be 121. That's 11. Well, you can do the factoring tree. Do you guys remember that? 2 numbers that multiply to be 121. And today we're going to come up with a bunch of different numbers, but this one is just the 11. And then you could circle it and it comes out and it's just 11. So the answer is just 11. Cross that out. Okay? Okay, so we're just going by simplifying here. The square root of 144 is 12. You'll know that by your factoring tree, right? 12 times 12, that's a pair. They can come out. The answer is 12. Well, that means the next one's going to be 13, 14, and this one should be 15. That was a mistake, right? So it should be 225. The square root of 225 is 15. Okay, what is 13 squared, class? 169. So if you take the square root of 169, and that's why they call them a perfect square. Everyone say perfect square. Remember, I'm not going to write out 169 chocolate pieces, but it's 13 and 13 on the sides. Now, we're eventually going to run into them where they're not perfect squares, which we're going to do on the other side. I'm on the top right here. I got 16. What number goes here? What's after that? After that? Here. 20. So I have 17. Whoops, that's 17. Oops, can't erase. 17, 18 squared, 19 squared, and 20 squared. Let's designate some colors here. Let's write it the same color. Red, you're going to put in your calculators 17 squared. Blue, you have this one. Green, and then orange. Okay, red chairs, 17 squared is? On your calculators, you can write 17 times 17, or you could do 17 to the power of 2. That little caret, it's called, like an up arrow. What was it? 289. Okay. Blue chairs, 18 squared? $324. 18 times 18 is 324. So again, when you think of perfect squares, you should be thinking of a square and then the same two numbers on the side. Green chairs? Oh, why did I assign you that? That's already done. Good job, green chairs. And then orange chairs. 20 squared? 400. Okay, so here we should see a pattern. Okay, I have 25, I have 24. So what number do you think this one's gonna be? 23, this one, 22, and then we have 21. Well, what does it mean with a little 2 up there? They call this a square, right? It's really an exponent as well. And so that basically means that you write it out 2 times. So it means 2 22s. 22 times 22. It does not mean 22 times 2. That would be wrong. And here's the reason why. These are the sides of a square. Yes? Put in your calculators. What is 22 times 22? 444? 484. Okay, so I can't draw it, but I'll attempt to. Imagine a piece of chocolate like a Hershey's, right? You're breaking it up for s'mores, and there are 484 little chocolate pieces. And each side length is 22, and this side has 22 pieces of chocolate. Are you following? So 22 times 22 is 484, or we call this what? 22 what? We made a square. Oh, that's why they call it a square. Okay. So to complete this line, that means 400 square root of 484. Class, we said that there was a number up here. What's the number? It's a 2. Okay, story time. I used to work at a scary place. And I asked the students, I'm gonna go jogging around the park at night. And they looked at me and shook their head and said, don't do it. And I said, why? If you go jogging around the park, you can get stabbed. I said, what? So, you need to find 2 identical numbers. Well, we already did the math. It's 22. 22 times 22. Now you can actually put that in your calculator with the radical sign. Some of you need to press the radical, then 484. Some of you will have to type in 484, then the square root. But pay attention. Inside the radical or the house, you are safe. You can run around. But when you go out into the scary neighborhood, there's a street sign that tells you how scary it is. This one says you need how many? You need 2 people who are exactly the same age or the same number in order to come outside. Now, when you come outside into the scary neighborhood, you are back to back. You don't want to get stabbed. You don't want someone sneaking up on you. So from far away, it looks just like, everyone say, 1 number. The identical number on the outside is 22. Okay, let's try the next line. Class 21, 22, this one's gonna be what? 23. So 23 squared is equal to, tell me your answer, 529. Right? I want you to know that 23 squared is 23 times 23. Well, if I put in the square root of 529, 2 identical numbers that multiply to be 529, the answer is what? 23. There's 2 of them. They're a pair. They come outside the radical sign. So you don't need the radical sign anymore. The answer is just 23. Let's box our answers there. Go ahead and do that. All right, green chairs. How did you break up 75? 25 times 3. You got 75 cents. Break it up to 3/4. And the square root of 25 is 5. Okay, question. Where does the 5 go? Inside or outside? It goes on the outside. And what's left inside? The 3. So your answer is 5 radical 3. Raise your hand if you got that. Okay, now sometimes you're going to have some answers in the future where you might need to keep simplifying. Now I'm going to guess some of you chose 15 times 5. That's not wrong. I just want to show you this. You can break up the 15 again. 5 times 3 times 5, and then you have the 5 that comes out. Okay? Red chairs. Square root of 36, the answer is? Red chairs. Everyone stare at the red chairs. What's the answer? Just tell me the answer. It's 6. The easiest one is you would have looked back at your chart. Okay, so on your first quiz, I'm going to let you, right there. Where is it? No, we didn't do it. Should have been 36. Okay. Now, again, I want to choose something else. Let's say you didn't think of that. Some ways of breaking up are by 2. So you could have done like something like 18 times 2. Do you guys see any pairs there yet? No. Then you break it again. You can do 9 times 2 times 2. So do you see anything now? Yeah. Okay, pay attention. I'm trying to do something different here. So that's a pair that comes out. And the square root of 9 is what? 3. That goes on the outside. So the answer is not 32. The relationship outside is multiplication, which would be what? Still 6. Okay, so I'm trying to show you guys multiple ways. It's not just one way to get the right answer. All right, blue chairs. Square root of 16, your answer is? 4. Again, you can do the same thing as you did before. Maybe you didn't do the pairs. So it should have been 4 times 4. You can break that up again to 4 times 2 times 2. Okay? And the square root of 64 is? 8 is correct. Again, if you did something like 16 times 4, or you did something like 32 times 2, let's just do this one together over here. 32 would break up to what? 16 times what? 2. Don't forget this 2 right here. Yes? And then you have a pair. And then the square root of 16 is really 4 times 4, so that's a pair that comes out. And then 2 times 4 is 8. Okay, in questions 5 to 8, the trick is to get perfect squares in here. But obviously they're not a perfect square. So here is a way to approximate. For example, this, whoops, that's not a number. The square root of 80 is smaller than the square root of 81. And the square root of 81 is what number? 9. So I know my answer, if you put it in your calculator, is going to be less than $9. Are you following me? It's like $8 and change, okay? But what we're going to do here is we're going to simplify this using factors. Factors are by multiplication. So I'm going to come up with all of the numbers that multiply to be 80. I don't know how many there are. And what I'm going to do is I'm going to try to find the perfect square, the largest perfect square. So for example, 80 times 1. 2 times what? I don't think 3 is going to work. How about 4? 20. 5? How many $5 bills in 80? Too much, too much. 60. How about 8? 8 times what? Did I miss any? Okay. Go ahead and talk to your partner. Which one of these pairs is the best one? They all work, but there's one that's the best. Tell your partner which one. Class, what shape am I drawing? A perfect square. Oh, that's why you teach us, mister. Oh, yes. My goodness. Okay, look. 16 times 5 and 16, this is factoring tree. You guys know that? Okay, I was helping someone, and the common thing they forgot is right here. I'm gonna try to do it in a different color. They just didn't bring down this 5. So 4 times 4 times 5 will bring you back to the original problem, 80. But remember the story I taught you, this is a scary neighborhood. You need how many people to come outside the house? 2. So there, circle it. These 2 can come out, but when they come out, does it look like 2 of them? It looks like what? Just one number. So you're writing a 4 on the outside. What's left on the inside? 5. 4 radical 5 isn't called an exact answer. So if you put in your calculator, square root of 80, don't do that. It's going to come out like 8.97. That's bad. That tells me you don't know the math I just taught you. I want the exact answer. Now, let's pretend you picked the wrong one. I know. You're like, what should I do? Let's say you picked 20 and 4. Not bad, but it's just more work. Watch. 20 times 4. The 20 will break down to what? Hey, you're not talking to me. 5 times 4, don't forget this one, times 4. Now, do you guys see the pair? Yeah, and it goes back to the same thing. So you just have to do more work. Now, I do want to also encourage you when you simplify, that means that the number on the inside, called the index, you cannot simplify again. So a quick one is if it's an even number, you probably need to double check. Okay? Let's try number 6. With your partner, think of all the factors. Ready, set, go. Michelle, give me a pair. 2 numbers that multiply to be 30. 5 and 6. Joseph. Okay, I already got that. Give me another one. In multiplication, you can switch the order, right? Is it still the same product? Oh, just told you that. Give me another one. Yes. Eileen. And then Giovanni got the last one. Think monies. We got $5 bills, you got $1 bills, you got $10 bills. Yes. Giovanni, last one. Money. 10 and 3. Partner A, have we talked about partner A awesomes? Yes? Shake your heads. Partner awesome, tell partner brilliant, which one are we gonna pick and why? Okay, I'm thinking to myself, there are no perfect squares. Raise your hand if you knew that. Okay, so I'm probably gonna pick one that's most broken down. So look here. Let's try this. That is 10 times 3. And then that turns into what? Okay, I just want to pause right here and tell you what this is called. These are called prime factors or prime factorization. And basically what it means is you cannot break it down or simplify it anymore. Okay, prime numbers, right? 1 times 7. 7 is a prime number, it's just itself. But when you break it down to the prime factors, it's not bad, it's just a lot of work. You can dig a swimming pool with a spoon, or you can dig it with like a really big power machine. Does that make sense? So it's okay to do that. In class, do you see any pairs here? there are no pairs, so you cannot simplify anymore. The square root of 30 would be your answer. Okay, look at your color chair. Blue chairs. What number did you guys pick for the square root of 8? How do you break it down? 4 times 2. Okay, now what? Oh, do it again. Oh, don't forget that one. Orange chairs. What goes on the outside? Green chairs, what goes on the inside? Yeah, don't forget that guy. Didn't have a pair to go outside with. Your answer is 2 radical 2. Raise your hand if you got that. Good. See, math is a process. It's not just I have the answers. Red chairs, what numbers did you pick? Maybe a better question, orange chairs. What number should you not pick? You should not pick 6 and 3 or 18 and 1. Does that make sense? You should pick what? 9 and 2, because 9 and 2 turns into what? Oh, that's a perfect square. And then you should circle the what? Circle them. Now, that sounds like an easy strategy, but eventually I'm going to give you cubics. Eventually I'm going to give you variables. So doing this simpler things is going to be good for us. They're a pair. They come outside of the scary neighborhood. They're right next to each other. And who's left inside? Too little. Your answer is what? 3 radical 2. Araceli, can you tell me all the numbers that multiply to be what? 32. Okay, 4 times 8. Keep going. Three times 2 times.
32 times 1.
There you go. 32 times 1. Mateo, you here? Mateo? Thanks. Yes. Any more?
4 times 8.
I think we got them all. Is that right? Okay, so there is one that is good, and there is one that's the best. Talk to your partner. Which pair is good, and which one's the best one? What do you think? Ready, set, go. Ready? 8 times 4. Raise your hand if you saw that. Okay, let me explain why. Ready? 32 is 8 times 4. Yes? And then we did this thing back in, like, I don't know, 3rd grade, the factoring tree. Yes? And 8 breaks down to 4 times 2 times 4. Class, what's the number up here again? 2. Do you see 2 numbers that are the same? What are they? Circle it. This is the number that goes on the outside. Pay attention. Who's left inside? 4 radical 2 is our answer. Okay, this is called an exact answer. That's what I'm looking for. You're not putting in your calculator the square root of 32. It's going to give you a decimal. That same decimal is the same as 4 times radical 2. But decimals are estimates. They're not exact. Okay, so which one's the best one? Do you know why that's the best one? Because it's the largest perfect square. Are you following me? Watch. Let's see if it does less work. 16 breaks down to what? 4 times 4 times 2. Now you could have chosen 8 times 2, but I went the 4s. Because, do you see a pair? That comes out, so my answer is 4 on the outside, right? Just one number. And then inside is what? 2. So I wanted to show you that you could have chosen a good one, get an answer, but the best one was a little bit less work. Okay? Let's try another one. Let's try number 10. Class, together, I want you to shout out all of the numbers that multiply to be 12. Ready, set, go. Okay. I don't know if you noticed the strategy. I put the larger number on the left and smaller number on the right, and then I started with 1 and I worked my way up. That is a very good strategy, okay? Tell your partner which one do you think is the best one. I'm looking for the perfect square. Da, 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 da. Okay, why did I pick that? Because what? You get a pair because 4 turns into what? 2 and 2. Do you guys see a pair there? Where does it go? Pay attention. And it has to go on the outside with no radical symbol. This is your answer. Ethan, how did you break down the square root of 8? 4 times 2, yes. Did you break it down again or did you just get an answer? You broke it down again? What do you get? Okay, Ethan did a good job because he listed that other 2. So one student stayed after class and was stuck at that point. So make sure you have that other 2 because when you multiply all those numbers together, you can get back to the index, it's called, the 8. I'm sorry, the radicand. Okay. Ethan, do you see any pairs there? How many am I going to circle? 2. Ethan, where does that go? And what goes on the inside? Raise your hand if you got 2 radical 2. Good. All right, let's try a harder one now. Eritzel, go ahead and tell me some numbers that multiply to be 108. Wait. Good. Anyone else? 54 times 2. 427. What was it? 36 and what? 3? Okay. Partner brilliant, tell partner awesome, which one is the best one? Ready, set, go. Crystal, which one is the best one? 12 times 9. Okay, this one is good because that is a perfect square. But Darian, do you know which one is the best one? 18 and 6. Okay, question, are any of those perfect squares? The numbers from the back. Yeah, 36 times 3 is the best one because we have this. So someone said split them up, you have a pair of 6s. And then who goes outside? And what's left inside? The 3. 6 radical 3 is our answer. Okay, so we just learned to put it in our calculators that this is like approximately 11.18. Okay, but that's not what I want you to do when we say simplify. 11.18 is an approximate or a guess. Everyone say approximate? That's just like close. But an exact answer has the radical sign in it. Okay? Now, I want you to think about all the numbers that multiply to be 125. Let's do them together. Shout them out. 5 times what? 525. What else? Anything else? Oh, I know one. 1 times what? Okay, I want you to notice the strategy. I've been writing the larger number on the left, smaller number on the right, and I'm starting by counting down by 1. 1 times 125. Well, half of 125 is like 2 times something, but that's a decimal. I don't want that. Not 3, not 4, maybe 5. Okay, I think we found it, so let's just use this one. The square root of 125 is, it's kind of like a factoring tree. So these over here you can write, these are called factors. That just means numbers that multiply. And I have 25 times 5. Well, we just did a whole page on these. You're trying to find, what makes 25 so special, class? Everyone say perfect square. That's what we were trying to find on the last page. Why? Because the 25 turns into what? 5 times 5. Now pay attention, I'm going to do this in red. I was helping a student and they forgot about this 5. Do you see that there? You cannot forget that one. Okay, now we're looking for pairs. Okay, I circle a pair, circle it. Where does it go? It goes on the outside. Your answer is 5 radical 5. 5 radical 5. Let's put that red one. That one inside, it has no one to go outside with. Does that make sense? Okay, let's try number 14. Got it? 14. Tell your partner all the pairs. Ready, set, go. Green chairs. Look at your colored chair. Green chairs. Five, 10. Blue chairs. What? 25 times 2? Red chairs. Come on, it's 6th period, we want to go home. What? Yes. Any more? Okay. Partner brilliant. We talked about this. Partner A, partner B. Yes? Partner B, tell partner A which one is the best one and why. Ready, set, go. Class, this one? No. How about this one? Yes. Yes. How about this one? No. Why? Let's do it. That breaks down to 25 times 2. And then 25 breaks down into what? 5 times 5 times 2. What am I going to circle, class? Yeah. Okay. Should I write 2 5s out here? How many? So 5 what? Radical 2 is your answer. So far you know to pick the best one is with the largest perfect square. Okay, class, help me write out the factors of 175. 175 times, what else? 5 times 35? Okay, with your partner, go ahead and pick which one are we going to use and why. Gotta ask him why. We're going to choose which one? this is called the factoring tree. So I have 25 times 7, because 25 times 7 is still 175. And the 25 turns into what? Pair of 5s. 5 times 5 times 7, that still equals 175. In class, what am I going to circle? Where do the 5s go now? How many 5s do I write? 1, 5. What's left? Just the radical 7. So when it goes outside, no radical. Stays inside, there is a radical. Raise your hand if you got 5 radical 7. Okay. Let's do the other one. So again, strategy, write out the factors. Listen for the perfect square. Yes, Mr. D. Yes.
So you have 35, say, if I try, you don't want to kind of rationalize, and you got 35 times 5, bring out the 5, then you go 7 times 5, and I got 7 times 5 times 5. I can pair up those 5s.
Yes.
That's still the same.
Mr. D, you found it. You realize that the other ones still work, but it takes a little bit more work.
Okay, so it takes just a little longer.
Because if you don't find the perfect square, you actually might realize that this one is not simplified sometimes. Does that make sense? I can cut my steak with a knife, but that knife's not sharp. It's going to take me a lot more work. Okay, let's try another one, see if it works out. Thank you for asking a question. Number 16. Partner A, tell partner B all of the factors for 28. Brandon, tell me a pair. 16. Tell me the pairs.
1 times 28.
Yes.
2 times 14. 4 times 7.
Brilliant, tell awesome. Which one are we going to pick and why?
2 times 4. 7 times 4.
Elijah, which one should we pick? Okay, so this is the best one. But as Mr. D was telling us that it's okay to use the other ones. Let's see, let's break down 28. Because, class, oops, I made a mistake. Tell your partner the mistake I just made. Ready, set, go. I didn't realize there's 2 Genesis. Genesis G. Can you tell me the mistake I just made? And what should it be? Raise your hand if you saw that. Good job. And then the 4s turn into what class? Whoops. 7, and that one is 2 times 2. Jasmine H, what should I circle? One of them or 2 of them? Both of them. And what do I put now? Where do the 2s go? Do they stay on the inside of the house, the radical sign, or the outside? Yeah. Raise your hand if you got 2 radical 7. Good job. All right, orange chairs. Tell me all the factors. Numbers that multiply. 5 and 9. What else? 45 and 1. 15 and 3. Do we see any perfect squares there? No. I probably pick. Well, I do. Yeah. Remember, this is the number you want to find. Why? Because we just spent a whole half of the worksheet recognizing that 9 is a perfect square. Because 9 breaks down to what class? 3 and 3. And then we can circle a pair. What pair are we circling? Where does it go? What goes inside? 3 radical 5 is your answer. Now, if you have a calculator, you can actually put in radical 45, press enter, and it'll give you a number. And it should be the same decimal as 3 radical 5. But 3 radical 5 is actually more accurate. Okay, let's do number 18. Blue chairs. Give me all the pairs. 9 times 8. What else? 18, 4. 36 and 2. 17 and 1. More. 12 times 6. Good. Okay. There is one that's good, and there's one that's the best. Tell your partner which those two are. Good and best. This one is what? Good. Which one's the best? Oh, best. Let me do both of those for you. I know, you missed it. 9 times 8 is the same thing as 72, and then the 9 turns into what? Oh, that's why. Now I have to break down this one. 8 turns into what? Oh man, that's like 2, 2, 2. Too many 2s. So now we circle the pairs. Pay attention. What's left inside? Okay, it's not 32 on the outside, it's by multiplication. So 3 times 2 is what? 6 radical 2 is your answer. Raise your hand if you got that. Now, that one took me more steps, right? Sometimes math is not always about what's fastest, but more efficient. So let's look at the best one, 36 times 2. Class, what does that break down to? Oh, 36 is the largest perfect square. That's why it's the best. Oh, 6 and 6. Our 6 comes out. How many 6s do I write out here? Just 1. Okay, let's do number 19. Green chairs. What'd you pick? Now, you can also do it like this. You could do something like this. This is totally fine too. Did you notice that this is one big house and this is both separate houses? That's okay because your index is still the same. That implies that when you're multiplying them, they should always be where? Inside or outside? On the inside. The square root of 4 is? And can you take the square root of 5? 2 identical numbers that multiply to be 5? Are they whole numbers? No. So it would just be 2 radical 5 is your answer. And number 20. Red chairs, what are the factors? Hey. 75, 2. What else? 50 times 3. Say again? Yes. 15 times 10. Yes. I want to tell you guys a strategy. I don't know if you guys saw my strategy and listen this out. It'll be a future math lesson. Let's try. 25 times 6 turns into 5s. So there's a pair that goes where? Outside 5 radical 6. Now I'm just going to check. Can I break up the 6? Yes, I can break it to a 2 and a 3, but are there a pair of 2s? Are there 2 3s? No. So 5 radical 6 is my answer.
Stitch, you think you could help me? I'm currently stuck on a problem because I don't know what step to do first. I don't know whether to add, subtract, or do parentheses.
Yes, I love math, so I can help you. So what you have to do is thou shalt honor the correct order of operations, which is one of the 10 math commandments.